Okay, it's time for test recording number 2. So for our first example today, we're going to talk about the following theorem, which is that the product of two integers is even if and only if one of the two factors is even. In first order, that's saying the following for all two integers, right? We got to quantify those two guys. The product is even if and only if one of the two is even. So this is A is even or B is even, right? Okay, so this answers pretty much any conceivable question you could have about even and odd and multiplication. What this says in particular is even times odd is even because one of the factors is even. Odd times odd is odd because not one of the factors is even, like neither of the factors is even, therefore the product also cannot be even. So odd times odd is odd. Even times even clearly satisfies this, so it's going to satisfy this. Odd times even, so that's all of them. And it is also reverses. If the product of the two integers is odd, then they must have both been odd. And if the product of them is even, then one of them must have been even. So if you knew that this was even, but this was odd, you could conclude that this was even. Okay? So we're going to prove this in a second.